Hello world, welcome back to this tutorial on building a Linux from scratch system. Now we are almost through with chapter 8 and the only things that are left for chapter 8 are the ones that are specific to System-V Init, and in this branch of this video series we will be using System-V Init. So yeah, let's just jump right in and see what we still have to do. We need to compile UDEF, proc psng, util linux, e2fs procs, sysklockd, and sysv init. Then we'll be through with chapter 8. Okay. Okay, these are already installed. Yeah, I think we can now compile these again. Okay. Okay, let's check the log files. Okay, the log file for syslog_d looks a bit suspicious. There are several warnings here, and it's quite short. But I don't see any severe errors, so I don't know, we might want to keep that in mind. The log file for System-V Init is also quite short, but I also don't see any errors here. Okay, so let's come to chapter 9. And I will create yet another script called inside change root for sh. I should really come up with more creative names here. Okay. Now, what do we do in chapter 9? Chapter 9 is about the configuration of System-V. It talks about how System-V works. And an essential part of the whole boot process using System-V are these boot scripts that I will just install. I think they really just copy some text files, scripts, into the etc directory, etc init probably. And I want to talk about these boot scripts in more detail, but in a future video. So for now, we'll just have them extracted, and that's gonna be it for now. Now, chapter 9.3, that's actually a chapter that I have been stuck on for quite a while, because chapter 9.3 is about UDEF, and that's a quite interesting thing, because it explains how the dev directory works. So it tells us that, I think before kernel 2.6, this directory didn't even exist. And I've always thought that the dev directory was managed by the kernel itself, but here I've been told that the kernel itself gives us the sys directory, and UDEF then looks into the sys directory, and from there UDEF creates the dev directory. Okay, I found that quite interesting, but okay. The thing that I was stuck on is it gives you a few details here on about how to configure UDEF, so that, for example, the different devices always should get the same name in the dev directory. And it's quite complicated what they discuss here, but I just didn't really get what that really means for me, because if I install just a regular Linux distribution, then I don't have to write a UDEF file. Okay, so in the end, I just basically decided to ignore that chapter and leave everything as it is, apparently the worst thing that can happen is that your devices just get different names in the dev directory when you reboot, and I think that's not so bad. So in 9.4 we have this call to a script that just creates a set of default rules for UDEF. So I will put that in here too. Okay, I'm gonna skip CD-ROMs because I don't have a CD-ROM here. And then we can already configure the network. So, and configuring the network, that's something that you just do sometimes when you run Linux. Okay, so now we will configure the network. I want it to be available on boot, yes. ETH0, it's the old naming convention. In my home network I have 192, 168, 178 numbers. Prefix 24 means that the subnet mask is 255, 255, 255, 0, a normal subnet mask. That means that when you communicate with devices that have the same first 3 numbers here, then we will ask the ARP system to give us a MAC address, and then we will send packets directly there to that MAC address. And for IP addresses outside that range, we will use the ARP system to get the MAC address of the gateway and send our data there. Okay. Let's see my current IP address. This was 30, so I will just use that. In the resolve conf, we set our DNS servers. So that's my router. It's a Fritzbox. It's a normal IP address for a Fritzbox. Setting the host name. The hosts file is, I would say something like the host file is an assignment of host names here to IP addresses, so that for the addresses in here you don't need to ask a DNS server. Okay, so now we come to the Init tab. And I think for me, at least, this is really the most interesting part of the whole project, because the whole boot process is what I'm the most interested in here. So this Init tab, you can look at the man page of Init tab. But I have to say, at least the German translation of that man page is not very good. So it tells us that the lines are values separated with colons, and the first column is just some ID, so something that can be 2 or up to 4 characters depending on your version of System-V Init. So you're probably better off limiting this to 2 characters. And the second column is the run level. And we've talked about run levels in the first video, I think. Your grub can pass a run level to the kernel just by having just a naked number 2, 3, 4 as a parameter, and the kernel will then pass that to the init system, sbin init, and sbin init will then check, okay, this here is for run level 0, this here is for run level 2, this here is for run level 4, and so on. So when you go into run level 4, it runs etcrcd init drc, and etcrcd init drc will then execute the boot scripts that are stored in, I think, etc init d for the different run levels. And then here's this wait that's in the man page. You can put different things in that column. For example, you can have respawn, which means that if this process terminates, then just restart the process. And wait means that it waits for the process to end. So this RC will end when all the boot scripts are executed, and then all the kernel modules have been loaded, everything has been set up. And then it continues with the next things here. These here are for run level 2, 3, 4, and 5. And they are restarted if they terminate. Sbin a getty creates these different TTYs that you can log into when you are in a text mode. I would like to show that with Control Alt F1, F2, F3. You can switch between them, but I don't dare do that right now because I'm afraid that my screen recording software might crash because of that. So you see, this is what creates the TTYs. This line here says that when you press Control Alt Delete, then it should shut down. And for run level 0, 1, and 6, we have this line here. The other ones a getty, which prompts you for a username and password, run level 1, well, strangely also 0 and 6, run sbin su login, which logs you in as root, but you still have to input the root password. So that's for system maintenance, like the safe mode in Windows. When you have problems with hard disks, for example, then you might get like you have some bad entries in your FS tab. Then some systems prompt you, please enter your root password for system maintenance, and then that would be done by SU login, and then you can edit your FS tab or whatever is broken in your system, fix it, and then you can continue booting. Now the boot scripts are put in etc rcd init-d, and then you will have the directories etc rcd, and then subdirectories rc1, rc2, rc3.d for the different run levels. And in there you will have symbolic links to the actual scripts here. And that's how this RC program decides if your scripts are supposed to start or stop their services. So if the symlink in etc rcd rc3.d starts with an S, then that script will be called with a parameter start. And if the name of the symlink starts with a K, then that script will be run with parameter stop to tell the script to stop whatever service it manages. Okay, system clock. Okay, here you can configure your system console. Since I'm in Europe, I think it makes sense to take this one here. So I have the DE Latin 1 key map, the euro symbol. I don't care much about the font. I've read that Unicode, turning Unicode on here can give you some problems. Okay. Then they have this file rc.site, which I think mostly sets some environment variables to the boot scripts. Etsy profile is, yeah, I would say a bash script that is run every time you start any bash. So here you would, for example, set environment variables that you want to have in every time that you run any bash. And since I'm in Germany, well, DE underscore capital D capital E is the German locale, and .utf8 is the default encoding. Another configuration file for the bash, and etc shells. That's also an interesting file. It says which programs are legal to be the default shells for the users. So if I don't know, if you tried to set bin Python as your default shell, then it wouldn't work because bin Python is not in this list. I think that's basically something like another safety feature. You know, users can change their default shell, so when they log in, they are allowed to set the bash or the Bourne shell as their default shell, and yeah, then that shell is always executed when they log in, and yeah, having this list is a little protection, maybe so that people don't accidentally, I don't know, set bin false as their default shell, and then they wouldn't be able to log in anymore. Okay, so that's all for chapter 9. So let's run that new script. These have already been compiled. keeps complaining that package install isn't found. Okay. I was running in the wrong directory. I don't know why we should change directory here. It can only create problems later. Okay, so this is these are the boot scripts being unpacked. And here we have the default configuration for the UDEF. Actually, I think that I think we want to change that. Okay, I think that's enough for today. We've done a lot today. We've finished chapter 8. We've gone through a lot of these configuration files. And especially the init tab, we've discussed the System-V Init process in detail. And yeah, we are now already through chapter 9. We are now ready for chapter 10, where we will compile the kernel, we will install the bootloader, and then we will finally boot this system. I'm really looking forward to that. So absolutely don't miss that. That's gonna be very interesting. And yeah, if you like this video, like it, share it, subscribe, and see you next time. Bye.